Welcome to this introduction course. This is the first in maybe a row of several courses. So that is the hazard-based standard 62368-1, and this is a general introduction to the standard, not detailed in technical issues. So the content of this presentation is first a small introduction to the standard, the three-block model, safeguards, operating modes, energy sources, components and subassemblies related to 65 and 950 today, and also different classification of persons. And also at the end, I will explain a little bit about the progress of the second edition. So what is it? It's a new safety standard. Covering product currently under the scopes of 65 and 950. That means consumer electronics, IT equipment and communication equipment, telecom and radio. And then it also specifies in the scope that it is a standard for components and subassemblies, and also for external power supplies intended to supply other equipment within the scope of this standard, and also accessories intended to be used with this standard. So it's very specified, the scope. So what is it again? It is hazard-based, based on sound engineering principles, research and field data, and it should be technology independent and allow for introduction of new technology easier and more design freedom. Information on the rationale for requirements is also an important part, which is the upcoming IEC technical report 62368-2. There's already a technical report out there, but that is related to the edition 1, which is not a European standard so far. So what is it not? I think there are some misunderstandings in the market. This is not a simple merger of 60 or 65 and 950, although there are many common elements you will see. And it's not a risk-based standard like we have in 6601-1. So risk analysis is not required during application and certification. So this standard has both requirements and compliance criteria. I think that's a misunderstanding out in the market. Decisions on application of requirements does not involve risk considerations. But of course, there were some risk analysis in the TC108 when it was developed for limits and levels. The objectives is clearly identify the hazard being addressed, clearly state the principles upon which standard is addressed, and also to preserve the basis of requirements, which is the rational document we have talked about. And it's also use of maximum IEC pilot publications and horizontal standards. So, and also use of international electrotechnical vocabulary. So TC108 has not tried to develop new definitions and new words. Almost all words have been taken from pilot publications and the IEV. And it should be performance-based, conformity-based on test rather than on the construction. It's a type test standard, useful for designers, suitable to assess conformance by suppliers, purchasers, and certifiers, like we have today in 65 and 950. And in the bottom here, should meet this in a user-friendly manner. That was the idea in the beginning from ECMA, which started this process and handed over to IEC, and this should be user-friendly. I'm not quite sure we are there, but it will be a standard. So what is product safety? Product safety deals with the risk of injury due to a hazard. and the main risk and main hazards are electric shock, fire. It's only internal. In this has been a lot of discussions about fire safety aspects due to ignition source external to the equipment. As we have talked about the candle flame issue. That has now been taken out of the IEC standard, and it's also taken out of the proposed EN. So there is still a discussion on 65, but that's another issue. So this standard will not implement the candle flame test for the external. And burn, hot surfaces, radiation, sound pressure, laser, X-ray, mechanical stability, sharp edges, moving parts, etc., and the chemical hazards. So what's an injury? An injury is a detrimental change to a body part resulting from an external influence and characterized by damage to any living cell or cessation of normal function of any organ. So then we come to the 3-block model. And then we first have the model for injury. And a product that causes injury does so through the transfer of some energy to or from a body part. So you have the hazardous energy source, you have the transfer mechanism, and the body part. So it's quite simple and what we know today. So one of the functions of a safety standard is to define the energy magnitude and the duration that are considered non-hazardous as a safety energy level, and the energy magnitudes and durations that are considered capable of causing injury as a hazardous energy. So then we have the 3-block model for safety, reducing the likelihood of an injury that can be done by having a non-hazardous energy source, and there is no safeguard, of course, and the body part can touch directly the non-hazardous energy source. And if you have a hazardous energy source, you need a safeguard to prevent the transfer of hazardous energy to the body part. So then what is a safeguard? This is a new word in this standard, which used through all the standard about safeguards. So it's quite important to really see what the TC108 has meant with the safeguard. So it's a device or a scheme or system that is interposed between a hazardous energy source and a body part and prevents hazardous energy from transferring to or from a body part. So the prescribed safeguards are intended to reduce the likelihood of pain, injury, and in the case of fire, property damage. So today is the same as, for example, insulation. So, but the safeguard is a general word for fire enclosure or whatever kind of barrier. That's a safeguard then. So to avoid an injury, the transfer of energy can be blocked by a safeguard. The safety parameters of the safeguard depending on the parameter of the energy source. So of course, if you have if you have a very big cat, you need a higher safeguard here, a better safeguard. And then we come to safeguard types, and then is the basic and supplementary. And you have the hazardous energy source, you have the basic safeguard, supplementary safeguard, and the body part. The basic safeguard is effective under both normal and abnormal operating conditions. And the supplementary safeguard shall be effective in the event of single fault of any part, including fault of the basic safeguard. So that's a principle we know from today. It's just, could say, maybe some new wordings. And you see the concept, it's not so difficult, it's just important to go through the 3-block model and to understand the concept behind this standard before applying. So then you have the reinforced safeguard. That's the same as we have for the double insulation. A reinforced safeguard is a single robust safeguard that is effective both under normal operating conditions, abnormal, and single fault conditions. That's what we have today. And then you have different kind of safeguards. You have first the equipment safeguard, as we know, insulation, barriers, enclosures. And then you have installation safeguards, which is a physical part of a man-made environment. It can be the installation in the house. For example, you can have insulating floor, that is an installation safeguard. Depending on, it could be a big product which is bolted to the floor, not to tip over. That's an installation safeguard. The personal safeguard is quite understandable, I think. A helmet, gloves, or whatever, and that is not controlled by this standard. So the personal safeguard is not directly controlled by the equipment, of course. So, but there are requirements in the standard, but not for the equipment. And then we come to the behavioral safeguard, which is a voluntary or instructed behavior intended to reduce the likelihood of transfer of energy to a body part or of self and others. So the behavioral safeguard is again split into 3 kinds of safeguards. You have the instructional safeguard, the precautionary safeguard, and the skill safeguard. The instructional safeguard is used for ordinary persons. The precautionary safeguard is used for instructed persons, and the skill safeguard is, of course, for skilled persons. Then we go to the operating modes. You have normal operating conditions, abnormal operating conditions, and single fault conditions, as we know in present standards also. But it's anyway important to just describe what is meant in this standard with normal operating conditions. Equipment safeguard should be in place and effective, and the basic safeguard parameters not exceeded, like temperature or whatever. Abnormal operating is assumed to be a temporary state. Any condition not a normal operating, example is a paper jam, blocked ventilation openings, or it could be, we know what abnormal conditions could be, I think. Of course, the abnormal condition can introduce a single fault condition. So, and equipment basic safeguards must be effective, but the basic safeguard parameters may be exceeded. And then we have the single fault. The supplementary safeguard parameters may not be exceeded, sorry. Foreseeable misuse is considered as a fault condition of a behavior safeguard, but could also be an abnormal condition. And the important part here, supplementary and the reinforced safeguards must be effective throughout the all of the above conditions. Then I mentioned about components, and the standard has introduced a clause about components for which are certified to 950 and 65. And those components are acceptable as part of this equipment covered by the equipment covered by this standard without further evaluation other than to give consideration to the appropriate use of the component or subassembly in the end product. This is the meaning of this is to make a smooth transfer from 950 and 65 into 62368. And this will also be taken out of the standard after a while. So this is just an interim introduction. And user components is what we have today, unless otherwise stated otherwise, where the component or a characteristic of a component is a safeguard. The component shall comply either with the requirement of this standard or with relevant IEC component standard. It's what we have today. Then we come to the energy sources. Electric shock, electrically caused fire energy source, thermal energy source, radiation energy source, mechanical energy source, and chemical energy source. This is also sources we know about today, so they didn't develop any new sources. And then we come to a critical part in the standard, the levels of energy sources. You have level 1, level 2, and level 3. And throughout the standard, the level 1 is used with the green color, and the level 2 with the yellow, and level 3 with the red color. So if somebody is printing out the standard, it should be printed out in color to easier use the standard. So level 1, non-detachable to detachable energy. Level 2 is detachable to painful energy. And then somebody is asking, what is painful? I feel it's painful before you feel it's painful, but it is described and specified in the different clauses. And painful to harmful energy. And for some energy sources, level 2 is classified as small injuries, not requiring professional medical attention, whereas level 3 does require professional medical attention, for example, cuts that require stitches. And then we have the classification of the energy source. Wherever it's possible, the energy source levels will be categorized into 3 classes. The level 1 is the energy source under normal and abnormal conditions, and level 2 under single fault conditions. So the class 1 can go up to class 2 in single fault. The class 2 is, of course, then exceeding the level 1, but not exceeding level 2 under all conditions. And then we have the class 3. So compared to present standard, I would say class 1 is similar to SLV today. Class 2 is similar to TNV. And then we have hazardous voltage on class 3. It's not directly comparable, but it's similar. So the energy source classification by declaration. This standard needs much more interaction between test house and manufacturer, because if we get a complex product, we have to go into the different parts of the standard of the product and define the different levels of the circuits in the product. And in some cases, that we need to get some help from the manufacturer. And some manufacturer, I think they will be quite in a starting point without knowing what they should look for. So this is a challenge for the new standard. But the manufacturer may declare a class 1 energy source as to either be a class 2 or a class 3 energy source. Of course, the manufacturer may also declare a class 2 to be a class 3. But then the safeguards has to be applied according to the declared class by the manufacturer. So if we as a test house cannot go in and declare energy source higher than the real energy source, then we put some more stringent requirements to the product and to the manufacturer. So that's not our possibility to do that. We have to measure. A neutral conductor is declared as class 3, of course, but the protective conductor is a class 1 and cannot be declared higher. So this is the main issue when we do testing to the new hazard-based standard. Try to find the different energy classes in the product and then set the requirements. This is a figure about required safeguard and the energy source that exceeds the body suspectability limits. This is taken from IEC, ISO IEC Guide 51 about potential sources of harm. And you have the energy source. Is it hazardous? No. Then it's like energy class 1 and you are done. There is no requirements. Of course, manufacturers may have some corporate requirements, but that's a different issue. If there is a hazardous energy source, then it can be a class 2 or it can be a class 3 energy source. If it's a class 2 energy source, you need to develop basic single safeguards. And class 3, you need to have a reinforced or double safeguard. So it's similar what we have today, but the concept is quite different. And then we come to persons. Requirements for applying safeguards could be different depending on the persons that have access. Then you have ordinary person, instructed person, and skilled person. Ordinary person is, of course, easy to understand. An instructed person is the person instructed or supervised by the skilled person as to energy sources and who can responsibly employ equipment and precautionary safeguards with respect to those energy sources. And the skilled person is what we know today. So, what kind of required safeguards do we need for the different persons? For the ordinary person, of course, no safeguard against detachable energies class 1. Energy equipment safeguards against painful energy, which is class 2. And also equipment safeguards against harmful energy, class 3. This is in general. There may be some clauses which deviate from these general principles, but this is the general in the standard. And for an instructed person, behavioral safeguard against painful energy source and equipment safeguard against class 3. But for the skilled, you don't need equipment safeguard. You can just have behavior safeguard against class 2 and also the same for class 3. So the standard goes quite long for skilled persons related to safeguards, related to behavioral safeguard and instructional safeguards. This is a picture of different safeguards. The ordinary person, the energy source class 3, they're of course basic plus supplementary or reinforced, and then you have an energy class 1, and then the ordinary person can touch this. From energy class 2, it's enough with basic safeguard to the ordinary person. But if you have energy class 3 and you have some energy class 2, you need double or reinforced between 3 and 2, and you need a basic from 2 to 1. And then for the instructed person, only basic safeguard and supplemental safeguard here then, but not necessary equipment safeguard. Energy class 2 is instructional safeguard. For energy class 3, basic and supplementary between energy class 3 and class 2, and then from class 2, instructional safeguard. And for the skilled person, energy class 3, a skill safeguard. And there is also, should be some prevention about unintentional contact safeguard. As we know today from 950, we also have that. And from the energy class 2 is a skill safeguard. And again, energy class 3 to energy class 2 is basic and supplementary or double. And then from energy class 2, it's enough with the skill safeguard. So the format of 62368, for each hazard, there is an objective in the beginning. It shall be an objective in the beginning of each clause to understand what is the meaning with this clause. I'm not quite sure if this has been the case in all clauses today in the second edition, but still work has to be done, and you never finish the document completely. It specifies the energy source as far as possible, the 3 levels, and define the limits between the energy levels, and also specify basic, supplementary, and reinforced safeguards. So the location of the safeguard, and the safeguard properties, and also the safeguard parameters with the materials, and also test parameters is put on in the standard. So the progress of 62368 is that the CDV2 passed the vote, the CDV1 for the second edition. We are talking about the second edition here. The first edition was out in 2010, and IEC said it should not be used. We should wait for the second edition, but few test houses has tried to do some testing to this, but it's not according to what IEC in the general meetings agreed upon. Anyway, the CDV for the second edition, the second CDV passed the vote, and we are waiting for the FTIs. It's I was at a meeting yesterday, and the information was there that the FTIs will come next week. And then from the FTIs, it's 2 months voting period. So it means in January, the closing date for voting will be. And then it may be published then in the early or mid next year as an IEC standard. And Europe, it also passed the parallel vote. The next voting stage will be in parallel with the FTIs. And it is assumed a transitional period with the legacy standards, 65 and 950, to be 5 years. So that means you will see here then the second edition of hazard-based standard will come out in the beginning of 2014, and the EN will come a few months later because there is a delay between the IEC and the EN. So date of ratification in Europe will be a few months after the IEC, and the date of publication is normally 1 year after the date of ratification in Senelec. So that means it will be, the date of publication will be in the middle of 2015, which is the latest date the standard has to be implemented as a European standard. And then the transition period will then be, if we expect 5 years, it will be from the date of ratification, 5 years, we come up to 2019. Then we have a transition period where the manufacturers can use 950, 65, or the new hazard-based standard, 62368-1. I don't think we will get the 3 year here, so this is the most likely time frame. However, we know that some countries may say that when the standard has been published as an IEC standard, some independent countries, of course not in Europe, they may say that no, there come a new standard. This should be implemented in our country. And then for manufacturers making product worldwide, they have to follow the IEC 62368 already quite early, maybe in the end of 2014, not waiting up to here. So we may have the challenge to do testing already in 2014 then. Of course, the voting has to go through, but my personal feeling is that it will go through. That's my personal feeling. And then we have the rational document, which I mentioned. That is a DC document. It's a committee document with, which is out for comments. And that will be the explanatory information related to the second edition of 62368. And that is a very helpful document which lists the different clauses and gives explanation why do we have this and the rationale behind. And also it's important for the technical committee to know that what happened in 10 years ago due to that discussion. Maybe all people from 10 years ago was not there anymore. So that is a very good document. For example, here then talks about energy class 1 energy source and gives some explanation and background. And if not all clauses has a rationale, but many clauses. And when a new proposal is taken into the hazard-based standard, the proposer has to also to give a rationale for this to be put into this document. So this will be a living document, and this is, as I mentioned, a technical report. It's not the standard, TR, technical report. This document is also on intranet, so you can look at this draft document, and I think it's quite useful when you read the different clauses in the standard. Look into the rational document also to get some more background. This is just an historical view of the history. Some of us has been in the business a few years and remember IEC 380 and IEC 435. I don't want to say how many years. And then those two standards became a merge to 950. And that was the previous TC74 in IEC, and then it became later TC108. TC92 was the standard for, development committee for 60065 for audio and video. And then today we have the IEC guide 112 for multimedia equipment, which is provided by ACOS, not by TC92 or TC74. But ACOS is advisory committee on safety in IEC EE. And then we are here today with the new 62368-1, which is not a complete merge between these two standards. But as mentioned, we will see a lot of elements from those standards in the new standard. Thank you.